Okay, so in this video, we're going to discuss the Mat1120 tutorial sheet 7, and I've already solved this. I'll just be running through the solutions that I solved. So number one has to do with using the factorial equations to evaluate 7 choose 3. So to show that, this is what we're going to have here. So 7 choose 3, we're simply using the formula n choose r is equal to n factorial, and we have n minus r, then we have r factorial. So this is what we are getting. We're getting a 35. This is your answer there. This was just me showing my working on the other side. Then the second one, 13 choose 2. This is how we do it here. We have 13 factorial divided by 13 minus 2. Multiplying 2 factorial. This is the simplification. So the 13 factorial contains 11 factorial inside. So no wonder we're just expanding it until we're able to see the 11 factorial there. Then the 2 there, that's 1. Then we have 2 there, that's simply 6, and 6 by that. Yeah, this gives us this guy here, because this is what is 265 by another 13, is it? Okay, so let me just try to redo this again here. We are saying we have a 13, so we're having a 13. Is it 13 times 12, 156, then divided by 2, we get a 78. Okay, so the working was okay. Yeah, so this is what we have. The same applies to number 3. They are separate, so we solve them separately. We solve this first and we solve this first. Yeah, so you should be able to get the answer that I got here, which is a 210. That's what you should be getting. So hope that's okay. We just use the formula. So I made this video with the thought that you've already learned the topic. Yeah, so for those who have not yet done the actual concept, learning the concepts, there is a separate video. For those that are registered, hopefully you've seen it in the WhatsApp group. So you have the next question is simply asking us to verify that the left is equal to the right. So we start with the left. We simply use the formula. This is going to be n factorial over n minus 2. Then we have 2 factorial. So we always expand to make the guy which is smaller. So you're having n factorial and you have n minus 2. So the one that's more is n minus 2, because this is n. Here it's n. You have subtracted 2, right? So the bigger one can always be reduced until we see the smaller one. The smaller one is n minus 2. The bigger one is n. So the bigger one, which is n, can be simplified until you see the guy appearing down. So if it was 3 here, it would have gone a step further until we see the 3, right? Yeah, so this is what we did here. That's the computation that we solved here, and you're seeing the n minus 2 cancelling. This is what you're going to get. Then the next one, you have n choose 3. This is what you get. Then from here, you simply express the whole expression there. You just reduce it. So n factorial is the same as n. You have this, you have that, until we see n minus 3. Then we can cancel this to just remain with that, which is the right hand side. The same applies here. This is your right hand side. So that answers your question number 2 and 3. Then question 3 is already there, available on YouTube. I solved this question separately. Yeah, so this is already done, so you can just check it out. On proving, we need to show that the left is equal to the right. So this is already done. Look at the next one. Number 4. They specifically said use the Pascal's triangle and the binomial formula to expand each of the following. Now, this is just for the purpose of the tutorial sheet. In a normal assessment, they'll always give you a power which is less than or equal to 5. That's always the case. And I want to believe you are okay with forming the Pascal's triangle. So the Pascal's triangle simply looks like this. You formulate it. We can add the subsequent terms to get this. This is what you have. So on and so forth. So staircase number 5, meaning the coefficients will be 10, 10, and it's 5 and a 1. and so on until you reach wherever that they want you to reach, the guy that you are evaluating. This is a 6, this is a 1, so on. So to show you how we did the first one, so here it's the same thing all the time. Just remember that the first term decreases in the powers as you move from left to right, and the second term increases in the power. So I just did the first one. You can do the rest. So the first one is here. This is question number 4. Yeah, so the power is 5, meaning these will be the coefficients from the Pascal's triangle, staircase number 5. So this is what I was implying to say the powers of the first term decrease. 2 to the power 5, 2 to the power 4, 2 to the power 3. You see that until we reach 0. The second term, the powers increase. When you evaluate this and simplify, 2 to the power that, that's a 32, that's a 16. This is what we get. Simplify it until we reach this. So this is the solution to question 4a. So some people would have left this in terms of 32, then plus, let's say, 8x to the power negative 1, plus 80x to the power negative 2, plus 40x to the power negative 3. So yeah, you can leave it like this. It's still okay. Yeah, negative 4 then plus x to the power negative that. That's still okay. So you can attempt the other questions, and then you can send for me to cross-check your working. So that was the guidance on question 4. That's what you need to do on all the questions here. Then look at question number 5. Question number 5, the powers are positive. That's one thing you can notice. And if the powers are positive, we always use the Pascal's triangle to expand something. So the only thing we need is to write the expression in the form of 1 plus something or 1 minus something. So like this first thing here, there's already a 1, so that's going to be 1 plus 0.02 to the power 4. Same applies here. We'll say 1 minus, how did I know? Just equate your 0.98, equate it to 1 plus x. Then so for x, your x here will be negative 0.02. So we're saying 1 minus 0.02 is simply 0.98. So that's the reason why we are going to replace this with that. And this is going to be written like that. I just solved for you the first one. So how we do the first one is how we do everything else. We let x be 0.02, meaning we're expanding this using the Pascal's triangle. This is what we got. Wherever there is x, we replaced back with it, the 0.02. Then we simply evaluate it. And the best way to do this is to just focus on the number. So like here, there's a number, right? This is 2. 2 times 4, that's 8. There are 2 decimal places. So that's what you get. There's 2 to the power 2. That's just simply 4. They're the 2 of them, meaning they're going to be 4 decimal places because you're having 0.02 times 0.02. There will be 4. 1, 2, 3, 4. That's the reason why we're going back like this to give us that. The same there. This is basically what we did. Then I'm adding this, giving me this answer. They just want the answer to correct to 2 decimal places. So this is what you are supposed to do on question number 4. So for verification, you can attempt this one and this guy, then send for confirmation, at least to see that you have understood the topic before you progress. So on number 6, I only did question number B. I think I did number B. Oh, I did x squared 10. This is what. Okay, so I did the first one and the last one. Yeah, so here we're just saying the first thing you need to do is to get the error. So we're using the formula for the nth term. The nth term, the formula is that the nth term you're looking for is equal to r plus 1. Yeah, so when they say find the 4th term, it simply means where there is n, we put 4. So this was supposed to say 4 is equal to r plus 1. The r is equal to 3. This is what we got as our r is equal to 3. We replace it in the formula to actually get the term. And then this led us to just get this term here. So we replace in the formula n choose r, a, n r, then you have b to the power r. This is what we use. And this term to get any term that you're looking for. So once you get your error, which is a 3, then we proceed and do the replacement. This is what we got here. So this is the answer that you should get. Then the next one, if they say the 60th term, meaning they want the error is equal to 5, right? So the next one here, the 60th term, I just got my error here, so that's my error. Then I replace in the formula. Then I solved the whole expression. Be careful with the fractions. Anything that can cancel, we cancel it. This is a multiplication here, not subtraction. So you'll notice that your expression is something like this. So we're having we have 18. So let's say we have 18 times 3, 18, this is 18 times 3 to the power 4, then times 7, then divided by, open bracket, 16 to the power 2. So the answer is something like a fraction. It's in a fraction form. Yeah, so leave it to be the way it is. We'll just leave it to be the way it is without simplifying anything. This is just going to be 18. Oh, so let me go back to here. So this is 10,206. So this is okay. Not sure if I even multiplied with a 7, but okay. Let me show you here. We're saying this is what this is 81 times 18, then times 7. Okay, so that's the 10,206. Then down, I'm having a 16 squared, 256. Okay, so leave it at that. This is what you basically get. Now the last one, not the last one here. We say this part here, we've gotten the term, right? They're saying find the term. So we found the term. This is the term. This is the 5th term here. This is the 6th term where r is equal to 5. So this is what you got. Yeah. Then the next one is question number 7. So question 7, they are saying in the expansion of this series, the coefficient of x squared is 250. Find the possible values of k. So we're going to use the formula for the series expansion. This is what we got. Then they are saying the coefficients, what's in front of x squared is supposed to be negative 250. It's the same thing as 250. So this whole thing, including the k, what's in front of the x squared. So now when we solve this part, we get this, then we square here, we'll get that. So the 10 here is cancelling. Then this is simply supposed to be k squared is equal to 25. Then we have them here, square root this is plus or minus this. So when they say the values of k, they mean plus or minus 5. Yeah, that's what they got. Then the next question, they're saying for each of the value of q, find the corresponding coefficient of x. So we have the first case. So the first case is simply when k is positive. The coefficient of x in the expansion is not even that hard. It's simply here. What's in front of x, right? This part. Yeah, so where there's k, put -5. Again, put +5. We see the two values of expressions we get. So these are simply the two possible coefficients of x. We can have a -20 if k is positive, and we can have a 20 if k is negative. And the next question is also related to question number, the previous one, to, if anything, number 6. They are almost the same, except here we're finding the actual term, right? So I did the first, I did A, C, and E, and I left these two for you as a task. So this is what we have here. So the first one, they're saying the term that has x to the power 5. What term is it? So we're using the nth term formula, which is simply n choose r. Then we say a to the power n minus r and b to the power r. So this expression here is going to be used. This is what we did, and equate it to the x to the power 5. Then from here, we're simply getting the portions that have x alone. So just get the part that has x, even here the x, but it is at the bottom, and I'm picking it to be down, this part. The bases are the same, the powers can subtract. So this is what we do, and we get the r to be 5. When r is 5, you can add it to 1, then you get the term. So it's the 6th term that they are looking for. Same applies for number C. We're just going to replace the whole thing in the nth formula and equate it to x to the power 9. Get the portions that have x alone. There's this x down, so this is a multiplication. So we're going to get this. And once you reach here, we can equate the powers. This is what you get. You solve for r, and your r is simply going to be your 3. Once you get your r to be 3, you can add it to 1, gives you the term, which is the 4th term. Yeah, then the last one on E, we equate it to q to the power 8. Now, they just want q, right? They didn't want anything to do with p, because the question here has p squared over 2 plus q squared. So we're only interested in q. Which term has q to the power 8? So we just get the portion that has q, which is this part, equate it to this. That's what we got. Our r to be 4, add it to 1, gives us the 5th term. So that's what you have. The next question, which is number 9. So you can try these two and just show me whether you understand and give me the answer. Question 9 is the same, except they want the coefficient. So I did B and I did number D. So for B, it was straightforward. We just express everything, equate everything to x to the power 20. Then from here, we get our value for r. So once you get your r, which is simply your 4, right? This is what we did. You replace it back in the original expression to actually get the coefficient they want. So this is all the working here. You can just follow through. It gives us the final answer. This is what we get as the coefficient of x to the power 20. Number 9D, we have two expressions. There's one that has x to the power, the highest degree here is x to the power 2. The other one here is x to the power x plus 2 to the power 6. So we'll expand this using the Pascal's triangle. Then we multiply with all these terms there. That's the best way to do it. But we're only going to be interested in portions that give us x to the power 4, not everything. So when you expand, leave this guy untempered with. When you expand your right hand side and come up with the equation, so what we got here was we got this expansion here on the right. So I'm just interested in things that are going to give us x to the power 4. That's what we are multiplying. So like 1 to the power 60 x to the power 4. So it's here. We have 3x times 160 x squared x cubed. So meaning this will turn out to be x to the power 4. Then we have the last one. We have 1. This is this is being related to when we multiply it with 60 x to the power 4. That's the only time we get the expression that has x to the power 4. So here now we can add everything. Yeah, and this we have that. The coefficient of x to the power 4 is simply a 300. That's the coefficient. So you can do A and C, then show me where you're going to get stuck, then I'll be able to guide you. So the next question that I did is number 10. 10, they're saying find the term independent of x. Whenever they say that, they mean the term that has x to the power 0. That's what it means whenever they say the term independent of x. So I've done the first one, then I'll leave this to you as a task. This is number 10. Number 10, we have this whole expression equated to x to the power 0. Then let these values give us the x expression. So we have x squared to the power this is what you see, then x to the power r. So from here we can bring it to be x24 minus 2r, then minus the r, then the expression here. So this is going to be, we're subtracting everything, so let me just show you here. So it's the same as x24 minus 2r, then minus r is equal to x to the power 0. So we equated the bases, right? The powers, this and that. When you solve it, that's how we got our r to be 8, meaning the nth term is simply the 6th term. So the 9th term, because its nth term is equal to r plus 1. So r plus this, this guy here. Yeah, so the answer here has to be 8, meaning it's the 9th term. It's the one that's independent of x. The next part, question 11. So question 11, they want us to expand up to the fourth term, meaning x to the power 3. So this is what we do. The first one here, this is what we do. So we're going to use the series because the power here is a fraction, and the series says provided the first term is a 1, you can always use the following formula. This is NA, n minus 1, then with an n outside, 2 factorial, a squared, and so forth. Yeah, so this is basically the formula used. Just be careful on the fractions. So this is what you get. This is supposed to be your answer. It's a series, it's non-terminating. That's the reason why we're showing this. The same applies to D. We just have to put it in a way that will be comfortable with expanding it. Your A is X, your N is simply negative half. So this changed, it became that, then we change this to become that. Then this is just an emphasis to say when the first term is not a 1, you have to make it a 1. Look at what happened here. We factorized it outside. To leave this first term to be a 1, that's the only time the whole formula thing works. So this is always supposed to be a 1. So this is what we have. So same applies here. It qualifies because this is number 11. I think I started to do 4 of them. So the ones that I've ticked are the ones that I've done, and the ones I've not ticked, that's your task. Then number 12, we have to write the expressions properly. This here is the same as 1 plus x squared. So at the end, we multiplied back the 1/8 with everything. So this is what you get.